Okay, so next we're going to talk about hemoconcentration and hemodilution. Okay, so this ties in really well to what we just talked about. And so those are our two objectives for this one, for this lecture. We're going to start with hemoconcentration. Okay, so at the very end, or one of the last things that we talked about in the last video, was the idea that generally during exercise, you're going to sweat. Why are you sweating? Because your core temperature is higher than normal and you're trying to get it back down to normal. Sweating is what cools you off. Okay, this is great. It keeps us cool, but this comes at a cost, and the cost is that we decrease our plasma volume. Okay, and depending on how effective of a sweater you are, this can actually reduce your sodium plasma, or excuse me, increase your plasma sodium concentration. So this is concentration. All right. And so it's important to remember that. I'm sorry that this word isn't on there, but we refer to this as hemoconcentration. Okay. And I'm actually going to change this while we're here. So concentration, right? So you didn't know that could happen, but there you go. All right. So we increase sodium concentration. That causes hemoconcentration. And so as a result, we release vasopressin from our posterior pituitary. Vasopressin, or antidiuretic hormone, that's something that causes us to hold on to water. And so what we're doing is we're trying to prevent the loss of excess water. We're trying to prevent that severe dehydration. So what happens to plasma volume when we train? Okay, well, when you train, when you work out, you do these things, proteins leave your muscle. Okay, these proteins enter into the plasma. Water, just like it follows salt, so water follows salt, water also follows proteins. It just sounds like water is a follower, right? It's not a leader, it's a follower. There's probably a pun in there somewhere. And so what this ultimately does is that we increase our plasma volume. So just the act of exercise, of training, of proteins leaving your cells, you're actually causing yourself, or you're creating an environment where water wants to stay. Okay, it wants to hang out with the proteins. The fact that we activate or release vasopressin helps increase plasma volume as well. Okay, and so this can tie into something called hemodilution. So first question I have for you is, well, what is hematocrit? And hematocrit, simply put, is just the percentage of your blood that is made up of red blood cells. Okay, and so the way we figure this out is we take a small blood sample, we put it in this little glass tube, and then they spin it. And what happens is the plasma and the red blood cells separate. They measure it, and then they divide. They figure out, if the tube is 3 inches long with plasma, if 1.5 inches of that or whatever is red blood cells, they say your hematocrit is 50%. So it's the percentage of the volume of blood that is made up of red blood cells. So what do you think hemodilution is? Well, hemodilution is the exact opposite of hemoconcentration. Hemoconcentration is we don't have a lot of water, but we've got a lot of everything else. Hemodilution is when our hematocrit decreases because we've got increased plasma volume. Okay, and so when this occurs, this isn't because we're losing red blood cells, it's just occurring because we're increasing plasma volume. And there's some effects that aren't necessarily ideal when it comes to this. Okay, and so one of those is if I've got less red blood cells in a volume of blood, that means that blood can deliver less oxygen. Okay, now we can make up for this by increasing our cardiac output, but the problem is that comes at a cost, right? If my heart is working harder to deliver the same amount of oxygen, then I'm not going to be able to go for the same time or intensity or whatever. Okay, and so we want to counteract hemodilution, and really the only way to counteract it is just to wait. Okay, and so time. And so if we're hemodiluted, ultimately what's going to happen is there's going to be changes to the hormones of vasopressin and aldosterone. And what will happen is we get rid of the excess sodium. And this is if we've got a high sodium concentration, or not even if we have a high concentration, but we'll just get rid of sodium. And by getting rid of sodium, we're going to get rid of water. Remember, sodium or water follows sodium. And so if we're hemodiluted, by getting rid of salt, we get rid of water. and as a result, our hematocrit goes back to normal, and then we're able to deliver the same amount of oxygen that we did normally.